Okay, so we're going to evaluate the definite integral, and the first thing we need to do is antiderivative, sort of implying that that's a verb, but it's the antiderivative should be a noun. But we have to. This one doesn't really jump out as obvious, but one thing we can see is that the denominator of this fraction is a single term, cosine squared theta, and when you have that, you can break up a fraction into two pieces. And it turns out that that's going to do the trick here. So I have 1 over cosine squared theta. I can break up the numerator, but not the denominator. Cosine squared theta over cosine squared theta, and all of that d theta. Now, next is we have to remember that 1 over cosine theta is secant theta. And so this gives secant squared theta. And then cosine squared theta divided by cosine squared theta gives 1. And each of these functions we can find the antiderivative. So the antiderivative of secant squared theta is tan theta. So you know we know that hopefully that the derivative of tangent x is equal to secant squared x. Okay, so I'm using the variable theta, but that antiderivative is tangent theta, and then the antiderivative of a constant 1 will be theta because the derivative theta is 1. And then I evaluate from 0 to pi over 4. And so I'm going to get tangent pi over 4 plus pi over 4. So I replace theta by pi over 4 minus tan 0 plus 0. Tan 0 is 0. Tangent pi over 4 is 1. If we, of course, it's better if we just knew that, but we could do a right triangle where, if you remember, that pi over 4 corresponds to 45 degrees. And sometimes I set up the triangle like this, where we should all know that this is an isosceles right triangle. So I have whatever sides I made them 1 and 1. I can find that the hypotenuse by the Pythagorean theorem. And then tangent is opposite over adjacent, so that's just 1 over 1, and that equals 1. So anyway, so I get 1 plus pi over 4, tangent pi over 4 is 1, and minus 0, and unless I'm missing something, that should do it. So just verifying, trust but verify. Number 37 is right from the back of the book. I suspect that there's a sort of a similar thing going on in 39. 39, I can't really look at quickly and see that that's the case. That I use that same trick, but I think that's what's going to happen. The other one I could sort of see more quickly. So let's go from 0 to pi over 3. Looks like we'll have a little bit more trouble. We'll probably have to find sine and cosine of pi over 3 or something. And it's going to be a little bit more of a, whoa, hold on. This problem is written down wrong, so that's not good. We can just see that I've sine theta twice, so it must have been that something's not good about that one. Don't want to ruin the whole video on this, but still. Let me just look that up and fix it, hopefully. So what section is this even? 5.4. Oh, this is number 38, actually. Did they do it? Oh, no. Okay, sorry. It's written down right, but this isn't 39. This is 38. But let's go for it. But the problem is the answer is not in the back of the book. Somehow I misread that and thought that was a plus. Okay, so far then so good, except it is number 38, not 39. So we won't get an answer in the back of the book, but I think we're still going to get something along the same lines of simplifying here. The way I set this up, I don't have as much space as I should, maybe. So, okay. For one thing, let's just do what we know is true, is that 1 over secant squared theta is cosine squared theta. So this is sine theta times cosine squared theta plus sine theta. Okay, I'm going to, well, let me just do this. Tangent squared theta, and then 1 over secant squared theta is multiplied by cosine squared theta. All of that d theta. And I have sine theta, cosine squared theta, and let's then call tangent squared theta as sine squared theta over cosine squared theta. And oh gosh, this is like not the easiest problem. I mean, I think I can do this for sure, but we're just going over easy ones. Okay. All right. So I guess we're, oh, no, maybe this will work out just fine. Actually, I think it's going to be easy. I was sort of panicking. Okay. So this is going to give us, well, what I can do is I can factor out sine theta from each of these. Yeah, and that's what's so much fun is that sometimes it looks like it's going to be a disaster, but look, factor out the sine theta here. Sine theta, sine theta, sine. Okay, so I'm going to factor out sine theta. And what does that leave? Cosine squared theta plus sine squared theta. Actually, I want to point out that I could have, if I were more clever, which I should be, that sine theta should have factored out earlier. Actually, this whole thing, this is not a good video. So if I just take out sine theta, I get 1 plus tangent squared theta d theta, and then on the denominator is secant squared theta. Well, secant squared theta is 1 plus tangent squared theta is secant squared theta. So I should have seen that, but I don't know, maybe because of the problem that came before, I was sort of distracted and I was doing it that way. But secant squared theta divided by secant squared theta is 1. So I would, and which I'm seeing down here anyway. Okay, I took a longer route by writing everything in terms of sine and cosine, but it all leads back to the same place. So that eventually this becomes integral from 0 to pi over 3 of sine theta d theta. I think because of the previous problem, I was trying to do this other trick, but it's way easier if I had just been smarter about doing this and just had seen that there's sine theta as a factor for both of those terms, and factoring that out, you use 1 plus tangent squared theta, secant squared theta, and then canceling. Now, the antiderivative of sine theta is negative cosine theta. And then it's up to me to get this wrong. I put in pi over 3, I'll take out the negative. So I'll get cosine pi over 3 minus cosine 0. Hopefully we know cosine of 0 is 1, and then cosine pi over 3 is 1/2, which can be seen by drawing a 30, 60, 90 triangle. So pi over 3 corresponds to 60 degrees. And if I make the hypotenuse 2, the short side is 1, and the height is rad 3, and cosine is cosine 60 degrees would be adjacent over hypotenuse, which is 1/2. So I get negative of 1/2 minus 1, which is negative 1/2, which is 1/2. Okay, so if the issue was, if your answer didn't agree with the back of the book, is because this was not 39, this is number 38. So that's number 38 and 37.